This is critical thinking in the endocrine lab. And in the endocrine lab, you would get images as well as histology, and then you have to do a little bit of the physiology. So this is one of the images, something like this you might get. Here is a histological image where you have to identify the region and then what hormones are produced. And this is a kind of question you will get in the test where based on the activities you do from your Physio XCD, the same activity is kind of related to what could happen in real life. So you have to apply that knowledge. Now let's look at the first question, which asks you, um, first is the hormones produced by region A act on, and then how is A connected to the structure it acts on? So first let's identify the regions. So this here, A is the anterior hypothalamus. B is the posterior hypothalamus. C is the anterior pituitary. And D is the posterior pituitary. So it asks you about A. So it says the hormones produced by region A act on. Now the hormones produced by A are the releasing hormones and the inhibiting hormones. So they act on the anterior pituitary. So that means they will act on C because you have the releasing hormones, for example, growth hormone releasing hormone. And anterior pituitary produces growth hormone. So naturally, the releasing hormone has to act on the anterior pituitary in order to have it produce growth hormone. Similarly, you have TRH, thyroid releasing hormone. Anterior pituitary produces TSH. So TRH will first act on the anterior pituitary and then cause it to produce TSH. So on. So that's how it acts on it. So A acts on C. So that is the first part of the question. So we have two which have C in it. So we have to choose between these two. Then it asks you how is A connected to the structure it acts on? So we have to see how is A connected to C. And if you look up here, you notice from A, the hormones, the releasing and inhibiting hormones are produced. They travel along this nerve tract and end up in these blood vessels. So they're secreted into the blood vessels. And then this set of blood vessels is connected to the pituitary. In fact, this set of blood vessels is known as the hypothalamo-hypophyseal portal system because the pituitary is also called the hypophysis. So hypothalamo-hypophyseal portal system meaning two sets of capillaries. So it is connected by blood vessels, hence this is the right answer. So hence it's very important for you to be looking at these images to know which hormones are produced by each one of them, or in the case of D, for example, hormones are not produced but they are stored, and you should also know how the hypothalamus is connected to the pituitary. Now let's go to the next question, which is a histological image, and here you have to first identify this region which the arrow is pointing to and then determine what is the main stimulus for secretion from the area the arrow points to. And then after obviously having identified that region, you have to see hypersecretion would result in what condition. So let's first look at the regions. So here is the capsule of the adrenal gland. This is the adrenal gland. This is the capsule. This area here where you can see these round structures like this part here like this, and I'm going to do that so that you can see that area clearly. This is the zona glomerulosa. So this area here is the zona glomerulosa. Then we have the zona fasciculata, where you can see these as bundles. They may not be so apparent in this image. It's a little small, but you can definitely see the change. This area here is the zona reticularis, and this part here is the medulla. So the arrow is pointing to the zona fasciculata, and it asks you what is the main stimulus for secretion from the area. The main stimulus for secretion from zona fasciculata is ACTH. So obviously these two choices you would look at. Renin-angiotensin is the main stimulus for zona glomerulosa, which produces aldosterone, and hypersecretion would cause aldosteronism, but that's not the zone that the arrow is pointing to. So hence, obviously, that would not be a choice. But if the arrow is pointing there, that would be the answer. But in this case, this is not it. ACTH, but that is true. ACTH is the main stimulus for secretion from zona fasciculata, which is this area. But hypersecretion does not result in adrenogenital syndrome. That is, adrenogenital syndrome is if there is hypersecretion from the zona reticularis. So hence, this is not a correct choice either. So let's look at this one. ACTH, yes, is the main stimulus, and hypersecretion from this area does cause Cushing syndrome. So this is the correct answer. And this is not one of the answers because this is to do with the medulla, which is this area, and the sympathetic nervous system is the stimulus, and if there is hypersecretion, it results in pheochromocytoma. So while this statement by itself is correct, but it is not the correct choice for this this question. So hence number 3 is the correct choice. So let's look at this third question where it tells you that Toby had his thyroid removed as it was cancerous. So which of the following hormones would he require to keep his basal metabolic levels normal? The reason is because if he has his thyroid removed, his basal metabolic rate would fall because the function of the thyroid hormones is to keep the basal metabolic rates normal. So let's look which of these hormones would bring his rate back to normal. So parathormone would not do that because the action of parathormone is to increase serum calcium levels. It has nothing to do with basal metabolism. Let's look at TSH. TSH also would not be a choice because if you see in the loop, where you have a hormonal method of secretion, TSH acts on the thyroid gland, and then the thyroid gland produces the thyroid hormones. Now, if there is no thyroid, there is no point giving TSH because it is not going to affect the basal metabolic rate at all because since there is no thyroid, no hormones will be produced. So there's no point giving TSH to this person. How about TRH? TRH also would not be effective because again, if you look at this loop, and let me show you this loop again. So if you look at this loop, TRH produced by the anterior hypothalamus, it's the releasing hormone, acts on the anterior pituitary to produce TSH or thyroid stimulating hormone. And then thyroid stimulating hormone will act on the thyroid gland, and then the gland will produce its hormones. Now, if you give TRH, it will act on the pituitary and produce TSH, but then the TSH has nowhere to act on because there is no thyroid gland itself because the gland was removed. So again, it would not affect the basal metabolic rate at all. So there's no point giving TRH either. How about thyroxine and T3? That is the correct answer because if you give thyroxine and T3, this is something that the thyroid should have produced, but it's not there. So instead, you're giving something that the body was not producing now after it was removed. So now when you give thyroxine and or T3, it will go into the bloodstream, act on all the tissues, and it will bring the basal metabolic rates back to normal. So this is the hormone that you would give in this situation, and therefore that is the correct answer.